going to do a feedback video for the position to term rules exercise, exercise 9.6. I'll also link the answers, which will be useful for you to check, but also talk through the sort of the thought process and how you should have attempted these questions. I know it's a difficult topic, so I think that watching this will be useful. Even if you check your answers and you got them mostly right, it'll still be useful to have a look at. So the first thing I'd say is, even though the questions start down here, there's a bunch of information at the top which you should read and should have a look at, because a lot of the time it will help you get in the right frame of mind and get you in the right sort of position to approach it. So we're going to know that we are going to generate terms of sequence using the position to term rule, and we're going to use linear expressions to describe the nth term of simple sequences. We've got a little bit of information about why people do it, so for scientific and economic reasons, and a bit of fluency, so a bit of sequences basics, which we've done in previous weeks, so just making sure we know what it is, what sequences are. So the seventh term, 1, 2, 3, 4, 5, 6, well, it's just asking the next term. It's going to be 15 because you're just going to add 2. I'm thinking of a number n. What is 3 times my number? So that would be 3n. 3 more than my number, so that's n plus 3. 2 less than my number, n minus 2. So it's just introducing a little bit of algebra in there, making sure you know that. And this explore thing, that's just for mainly for people who find this pretty straightforward, just to sort of extend them slightly. Okay, so if you thought all this works very easy, you could sort of explore something like this, and it'll give you a bit of sort of deeper understanding. Okay, but let's get on with the questions. So, warm-up questions. So this lets you know these are going to be fairly straightforward, and also on the right is key points, which are helpful hints. So first time you get stuck, have a look over to the right, see if there's a bit of help there. So write down the missing rule for the function machine. So what happens to turn 2 into 6 and 3 into 9? Well, in both those cases, it's going to be times 3. 10 into 5 and 11 into 6. You might look at that and think it's divided by 2, but then it doesn't work here. So what else could you do? You could take away 5, and that's the rule, because you take away 5 down here as well. And then here, 4 times 5 makes 20, and 5 times 5 makes 25, so it's times 5 in the middle, matching the expressions. So you could probably do this even if you didn't fully understand, because you just look at the numbers and see what they make. But just to be clear, 5 times n, that's better written as 5n. We don't need to say the times in algebra. It means the same thing. 10 fraction line 5, that means 10 divided by 5. 10 divided by 5 makes 2, so that's 2n. And then 2 times 9 makes 18, times n makes 18n. Okay. Right, then, next question is asking us to look at the shapes made from squares. We want to draw the next shape, so I won't actually draw it for you, that'll be in the answers, but just so that you understand, I'll describe how I draw it. So if you have a look, it starts with this line, and then one goes on the bottom, one goes on the top. One more on the bottom, one more on the top. One more on the bottom, one more on the top. So I draw the next shape. It look the same as this, except there'll be an extra one at the top, an extra one at the bottom there. Copy and complete the table. So shape number, that's the position. So, and then number of squares, that's the term. So if this is a numerical sequence, first term, second term, third term, fourth term, position, and then how many squares would be the term number. So 2 squares, 4 squares, 6 squares, 8 squares, and then for shape 5 it would be 10 squares. The term to term rule, that's pretty easy, going from next term to next term. It's just add 2. How many squares are in the 6 shape? So we don't need to draw it out, just add 2 onto 10, it's going to be 12. And copy and complete the formula to describe the position to term rule. So number of squares, well, the shape number, it's going to be times 2, isn't it? If we have a look, 1 times 2 makes 2, 2 times 2 makes 4, 3 times 2 makes 6, and that works, so it's times 2. Use the position to rule term to find the 10th term in the sequence. So shape 10, 10 times 2 makes 20. I need 20 squares. Question 4. write out the first 6 terms of the sequence for each of the position to term rules. Position number plus 6. So that's 1 plus 6 makes 7. Then 2 plus 6 makes 8. 3 plus 6 makes 9, and so on and so on. So each one you're going just 1, 2, 3, 4, 5, 6, and each of those you're adding 6 to. 2 times the position number. So 2 times 1 makes 2. 2 times 2 makes 4. 2 times 3 makes 6, and so on. 2 times the position number plus 1. So 2 times 1 makes 2, add 1 makes 3. 2 times 2 makes 4, add 1 makes 5. 2 times 3 makes 6, add 1 makes 7, and so on. And this one, 3 times the position number, take away 2. 3 times 1 makes 3, take away 2 makes 1. 3 times 2 makes 6, take away 2 makes 4, and so on and so on. You'll get the full answers to these in the attached document. And then write down the term-to-term rule for each one of the sequences. So if you've got the numbers written down, if it's position number plus 6, so that sequence is 7, 8, 9, 10. What's the term-to-term rule? It's just add 1. This one, 2 times position number, so that one went 2, 4, 6, 8. So that one, term-to-term rule is add 2. This one, so this sequence would be going 3, 5, 7, 9, is add 2 again. And this one would be going 1, 4, 7, 10, and that one's going to be add 3. So if we think about this discussion, what is the relationship between the term-to-term rule and position-term rule? So this one we said was add 1, and we've got 1 position number. This one was add 2, 2 times position number. This one was add 2, 2 times position number. This one was add 3, 3 times position number. So how many times you got the position number is how many you've got to add on each time. So that's the link they're trying to get you to discover there. Question 5. Look at this sequence: 6, 8, 10, 12, 14. Signy, I'm not sure of that name, said the position to term rule is position number plus 2. Explain why it's wrong. So this position number is 1. 1 add 2 is 3. Well, that's wrong straight away, isn't it? This position number is 2. 2 add 2 is 4. So that's wrong. So just showing an example of why it's not right. Okay. Then we've got a worked example. So this worked example goes through a lot of what the lesson last week goes through. So I won't go through it now, but I might refer back to it soon. Right, so question 6. This is where stuff's getting a bit more tricky. For each sequence below, write down the term-to-term rule, position term rule in words, and the nth term of the formula. This is the hard bit, the nth term of the formula. So for the first one, we've got 7, 14, 21, 28, 35 terms to term. So going from this way, it's going to be add 7, add 7, add 7, add 7. The position to term rule in words is getting from here to here. It's going to be multiplied by 7. And the nth term, 7n, because multiplied by 7 just means 7n if we write it in algebra. Okay, this one. So moving along here, we've got 4 to 5 to 6 to 7 to 8. The term-to-term rule is add 1. The position to term rule, so you might think it's times 4, but that doesn't work. So what else can we do? We could add 3, and that does work, doesn't it? So it's going to be position plus 3, and the nth term using algebra is going to be n plus 3. Okay, these ones, find the nth term of each of these sequences. So 2, 4, 6, 8, 10. Well, position number 1, position number 2, position number 3, it's just your 2 times table, so it's going to be 2n. This one, 10, 20, 30, 40, 50, that's your 10 times table. It's going up in tens. Think about that connection between if it's going up in tens in the term-to-term rule, that means 10 times the position term rule, so it's 10n. Number 8, discussion. So we've got to come up with the term-to-term rule for each of these. So that's going to be plus 2. This one's going to be plus 10. What do you notice between them? Like I said, plus 2 means 2n for my sequence. Plus 10 means 10n for my sequence. Okay, so STEM. science, technology, engineering, and maths modelling. Okay. Elena is training for a marathon. She runs for 12 minutes on her first day and then 12 minutes more each time she goes for a run. Complete a sequence up to the 6th term. So it's going to be 12, 24, 36, 48, 60, and 72. What's the nth term of the sequence? Well, it's just a 12 times table. So it's going up in 12s. Remember that connection. Up in 12s. So the term to term rule is plus 12. The position to term rule is 12n. What's the nth term of the sequence? 12n. How many hours will she run on the 10th day? Well, that means using that nth term, 12 times whatever the position is, so 12 times 10, 120. Do you think you should be able to stick to a model for 50 days? Explain your answer. Okay, let's think. So 50 days, that's going to be 50 times 12. That's going to be 600 minutes. 600 minutes is 10 hours. Do you think she's going to be running for 10 hours in a day? I don't think so. So I think it's just unrealistic to carry it on for that much. She'll probably reach some point where she runs for, if it's a marathon, maybe 4 hours, and probably that's as far as she'll go. Number 10. Well, how much does a monthly subscription to a real film rental site cost in total? It's easier to explore the question. Now I've completed the lesson. Okay, so this is the one which was asked before. So for this one, we've got however much it costs per month. That's just a monthly subscription. There's no end to how much it costs unless you know how many months you're going to use it for. So if you use it for 10 months, it's going to be 10 times whatever that monthly subscription is. In general, it's going to be n times that monthly subscription, where n is how many months you keep the film for. Okay, and what information do you need to know? You need to know how many months you're keeping the subscription for. Then jumps from question 10 to 15. So a pretty big jump there. But if we're going to reflect, think about term to term rules and position term rules for the 5 times table. Which rule is times 5? Which rule is plus 5? So times 5 is position to term rule, because first position times 5 gets you 5. Second position times 5 gets you 10. Third position times 5 gets you 15. Plus 5 is term to term rule, because you go 5 up to 10 up to 15. You're adding 5 going across. You're multiplying by 5 going down. We've got to know the difference between these. Okay. So you can write your own sort of hint if you want to help you with that. But what's important is the pros and cons of these. So term to term rule is easy to come up with. So going 5, 10, 15, 20 is very easy. And just coming up with the rule, so 5n, and using that might seem more difficult. But think about this question up here about 50 days. If we just had to add on 12 50 times, that would take a long time. Once we realize the connection is 50 times 12, that's much quicker. So it's got advantages there. Right, like I said, there's going to be answers attached. So check your numerical answers, because I said a lot of them, but you maybe didn't catch it, and also I didn't say them all. If there's anything you don't understand still, then you can let me know. And also, I'm going to be doing this topic more in school tomorrow. Okay, so this will sort of carry on, and you'll get a bit of extra help if you're in school. But even if you're not, you can email or message me, and I'll get back to you with some extra help if you need it. Okay, that's it for today.